And that takes us to the last topic that we're going to talk about in this lesson, which is something called access methods. The first access method that I want to talk to you about, and the one that is most prominent in an Ethernet network, is CSMA CD, which stands for Carrier Sense Multiple Access. Okay, so that's what the CSMA stands for. With collision detection. That's the CD, collision detection. What does this mean? Let's break down these words. Carrier sense. Carrier sense means that a computer that is working within a network that is designed to use CSMA CD has the ability to sense if there is data already out on the network, if there's already a signal out on the network. Multiple access means that multiple computers, and potentially all computers, have simultaneous access to the network. We'll say to the cable. Okay, we're going to say we have a bunch of computers, they're connected to a cable. Everybody has access to that cable at the same time, meaning anybody can send data when they think it's appropriate. Okay, everyone has access. So we're able to sense if there's already a transmission on the cable, and we're all listening at the same time. Now, I like to think of this as almost kind of like having a polite conversation. If you are politely communicating with another person, or we'll say others, let's say there's a bunch of people in a room. If you have something to say, the first thing that you do is you listen to see if anyone else is talking. And you only attempt to speak when nobody else is speaking. That's what we mean by carrier sense multiple access. We're all in the same room. We all have the ability to talk whenever we want, but we all know to listen and wait and see if someone else is done transmitting before we attempt to make our own transmission. Even in that environment, accidents can happen. Two computers might both be listening to the cable saying, I got something to say. I got something to transmit out on that cable, and well, it looks like it's free right now. Nobody's using it. And they're both thinking that at the exact same time, and then they both transmit at the exact same time. And then when they both transmit and that data goes out on the cable from both computers, that data does what's called collide, and that transmission dies. Because there can only be truly one transmission at a time. And I will tell you that there is a process that goes into play where you are able to sense that that collision has taken place, or detect. We want to use the literal word, right? Collision detection. When those two computers realize there's been a collision and their transmission did not go through, there is a process involved to help determine who would go first on their reattempt to send data, and then the other would go next. Now we have another access method which is similar to CSMA CD, and that's called Carrier Sense Multiple Access CA, collision avoidance. Now, where would we see this in today's world? You'd see this in many wireless networks. So it still could be part of what many will refer to as kind of like an Ethernet network, but it's the wireless component of it. CSMA CA. What's the difference? Well, we still have carrier sense, right? You can listen to the airwaves in this case. And by the way, CSMA CA does exist on cabled networks. It's just in today's world, you see it typically in a wireless environment. So again, you're listening to the media, whether that media be cable or airways, either way, and you wait to see if someone else is communicating. You make sure that the media is clear before you attempt to communicate. But now we use something called a collision avoidance. And the way collision avoidance works is when you have something you want to say, when a computer has a transmission, before sending that transmission, before sending the data out, it sends one tiny little packet quickly out onto the network that just says, I'm about to speak. It makes an announcement. I'm about to transmit. And that's how we avoid the collisions, by having that announcement go out. And when that announcement does go out, all the other computers on the network know, okay, I can't go until after I get a transmission from the computer who says that he has something to say. Now, obviously, there is a timeout period. Otherwise, you could see how you could really take down a network by falsifying these announcement packets and then never transmitting data, right? And the analogy I like to use is, I like to think of, let's put us all in a room again. There's a bunch of us in a room, and this time, if any of us have anything to say, we don't just say it. We don't just wait for quiet in the room, right? We don't just wait till someone else is done talking. You raise your hand. You raise your hand, and that raising your hand is kind of telling everybody, hey, I'm about to say something. And so when everyone in the room sees that a hand goes up, they all shut up and say, all right, we're going to be quiet until he puts the hand down and he says something. Now, I will also tell you that in a CSMA environment, or to be specific, CSMA CA environment, you can still have collisions. Okay, accidents can still happen. And those accidents are still handled the same way they are with CSMA CD. But I just wanted to say that this is, you can kind of see how there's an attempt at avoidance with that access method. Now, the last access method that I want to go over with you is something called token passing. This is a deterministic access method, which is not used nearly as much today as it was, let's say, a decade ago. It was typically used in a token ring network, and there is a whole long description of exactly how it works. But the basic idea is that you have this thing, it's a technical term, a thing. We'll call that thing a token. And that token, just picture it as anything you want. Just picture you have a bunch of computers on a network, and they're all in a ring. Okay, if you remember from the topologies lesson, they're in a ring. And this token, some people like to think of it as like a plate. Some people just say it's kind of like a coin. Some people think of it as almost like a statue. I've got the statue right now. I don't really care how you picture it, but it's this thing, this token, and it is passed from one computer to the next around the network. And it just keeps getting passed around and around and around. And the purpose for this token is that when a computer has data that it wants to transmit, it can only do so when it has the token. And that's what we mean by deterministic. We don't have that multiple access anymore. You can't just speak when you want to and then deal with it if it collides. You can't raise your hand. Everybody takes their turn. And what happens is if you receive the token and you have something to say, so you put the data out on the network. Now, some people think of it as they take the token and they keep it and they send data out. And other people think of it as if the token's like a plate or a platter, you put the data on the token. There's many different ways that I've seen this described. But either way, the one thing still stays the same, and that is the data must travel all the way around the network and get back to the original sender before the token is then released onto the next computer. Okay, so even though that data may have only been meant for one other computer on the network, it is passed to every other computer, and every other computer looks at it and says, oh, not for me, oh, not for me, oh, not for me. And then finally one computer says, oh, hey, that's for me. But even though that data was for me, I still need to continue passing the data on until it gets back to the original sender. The only thing I'm going to do is I might make a slight change to it, which would be an acknowledgement that I got it. That way the sender knows it made it to me. And so that's how token passing works. These are the three most common access methods used in computer networking and more specifically in TCP/IP.